Hi, my name is ChrisKopacz. This is the longer video that will provide a more detailed walkthrough of my final project for CSCIE59. The project title is Los Angeles Crime Statistics 2020 to 2024. I'd also like to note right at the beginning that although for the majority of this class we used an EC2 instance as the MySQL server with Amazon, I ran into difficulties with available computing resources when trying to import the data. So after a number of attempts, I just couldn't get it to work. It took too long, and I ran out of computing credits. So I ended up implementing the MySQL database as a localhost instance rather than through AWS. The data for this project is available on data.gov, and it details crime incidents that took place, or reported crime incidents that took place in Los Angeles from 2020 to 2024. The data is provided in a number of different formats. I ended up using the CSV version, which ends up looking like this. Each row represents a reported crime in Los Angeles in the given time span. There's a unique ID. There is date and time information. Interestingly, the area that the crime occurred is represented in a number of different ways. That'll become more clear when I show the ERD in a moment. Additionally, there is descriptive information for the crime, what occurred, as well as where it occurred. There's information regarding the victim, and then there's investigation status indicating open, closed, ongoing, that sort of thing. Now, that data that comes from data.gov provides 99% of everything I needed for this project. The one thing that it lacked was the MO code description. So that CSV provides everything except for this last column in the MO code table. Googling MO code LAPD produces or gives you a PDF that should be the first result. And MO codes are just further descriptive information regarding the crime in question. So right at the top, this 100 series is the suspect was impersonating someone, and then it gets more detailed. The 200 series is suspect wore a disguise, and then from there it gets more detailed, so on and so forth. So this PDF was used to populate this last column in MO code. The column name is MO code description in the MO code table. The rest of these columns and tables come directly from the CSV. The main table is crime incident. This is basically the entire row, but with the ancillary information split off into normalized lookup tables to prevent repeating information. Regarding location and area, so area references a geographic region, like a neighborhood perhaps, whereas reporting district is more specific to the LAPD and their purposes. It's like jurisdictions and precincts. So areas overlap with reporting districts, and reporting districts overlap with areas, vice versa. There can be a zero to many relationship or a one to many relationship, just depending on the scenario, but they both link back to details of a crime. Premise is another table that details the area or location of the crime, but it's more specific to or more precise. It'll be like crime occurred in a parking lot or in a single family home, in the street, something like that, the grocery store. It's not necessarily as general as area or reporting district. This happens to be specific to the precise location where it took place. And then location is more detailed information for these other three tables. Covers the street address, if it was in a building. If it wasn't in a building, street address is just a single street, and then cross street becomes available, just indicating the nearest corner to where the crime occurred. And then, interestingly, the data also provides a latitude and longitude, which allows us to plot it on a map if we want to. The incident victim table doesn't link to anything else. It's just descriptive information for who the crime was committed against. There isn't always a victim, say for like property crimes, but they certainly are for violent crimes. Back to the MO codes, each incident can have multiple MO codes. So it's linked to the MO code table through a bridge table where there's no uniqueness constraint. In the CSV, the MO code is a white space separated list of integer values. So there will be multiple incident IDs linked to multiple individual MO code IDs, and then from this bridge table, it links back to the MO code reference table. Once the database structure had been established, I built it in MySQL using a number of queries. This makeDB file is a SQL file that is really broken into two parts. First, up at the top is everything needed to create the database and then create the individual tables. For the purposes of the data import, I created this additional crime staging table so that essentially I took the data from the CSV and inserted it directly into the staging table without changing column names. This is a one-to-one representation of what the CSV actually is. And then the lower portion of this SQL script takes the data from the staging table and inserts it into the relevant tables in question to make it put it in a normal form. I had difficulty using the native data import or the data import functionality native to MySQL Workbench. I kept encountering an error regarding local infile. I set it to on or true and it still wouldn't work. So ultimately, taking the data from the CSV and importing it to the staging table was done in Python. That was accomplished with this script, import data from CSV, and it's straightforward with my local MySQL instance. It just uses SQL Alchemy to create a SQL engine. It uses pandas to read in the CSV. It sets the column names to a lowercase version. And then this is cleaning of the white space for a number of the fields in the raw data. SQL prefers the Python version none when representing a null, and then from there it's just connect to the SQL database and insert it into the staging table. After the data was inserted into the staging table, most of it could be broken out into the normalized lookup tables with straightforward simple queries. Just these are the fields we want, place it into this table with these column names. The two tables that I had trouble with were the crime table and the victim table. Every time I tried to use a straightforward standalone query for the victim table and the crime incident table, even though I was on localhost, the query would time out or the transaction would be canceled. It would break halfway through every time I tried. So I ended up using a stored procedure. I added a column to the staging table that just gave it an auto-incremented ID that wasn't in reference to anything else or used anywhere else. Just a counter for the number of rows that were in that staging table. So that when I ran the stored procedure, if it broke, or it would perform the inserts in batches of 1,000 and then perform a commit. And if it timed out or broke, then this stored procedure would look at the maximum staging ID that was available in the crime state or in the crime incident table, and then it would pick up from where it left off instead of starting all over again. So this highlighted portion here is the actual query to insert rows into the crime incident table, but it's just wrapped in a process that allows it to do it in batches. And then the stored procedure is called. And same thing with the victim table. I'm not sure why it was breaking, but the straightforward version of the query that I was trying to use to insert was right here, and then it's just wrapped in something that will account for the batch process or timing out. After that, I went back to Python to populate the incident MO code and the MO code tables. Because incident ID is linked to the white space separated list of MO code IDs, it was just easier in Python to clean that up and pipe it into the incident MO code table. So this script, mocodes.py, populates half of the MO code table and all of incident MO code table. Same thing, just a very simple open up the MO codes. Get the MO codes from the raw data, clean them up, split them on white space, and then populate the respective tables. The last column that up to now remains unpopulated is the MO code description in the MO code table. This comes from that extra PDF that I found online detailing the LAPD MO codes. And this Python script actually implements another Python package that actually can parse the PDFs. It's well structured, and it just takes the MO codes and then parses the description and then inserts them into the appropriate row in the SQL database. So now I can demonstrate few sample queries just to show that the database is functioning. This first query will just return the total number of crime incidents that were reported from 2020 to 2024. We have just over 1 million. And then from there, the queries can be more specific to aggregate the data however you want or filter it down. This second query is grouping by year that the crime occurred. So roughly the same. 2024 had noticeably fewer crimes than the preceding years. This last query is grouping by weapon type. And the top two are using fists or hands or unknown. The last thing I did for this project was to use that MySQL database as the backend for a Flask app that I also developed in Python. It's started from the command line. And once it starts up, looks like this. Just a very straightforward interface to run the different preset queries for the project. Some of the queries have visualizations. So this is crimes by year, the data that we were just looking at. So not only are you given the table version, but now you can see it in a plot. And again, the chart types are all hard-coded. It's very lightweight. I didn't want to make the app the focus of the project. Most of my energy was spent on figuring out the database and how to set up the tables. I just wanted to link it to something and add some visualizations and interactivity. The code for the app itself is provided in the deliverables for the project. It's very straightforward. Just set up a Flask app and then render it. The queries are pre-selected and they are all stored in JSON. However, because they are in JSON, the query string is all on one line, which is not readable for humans. So I've also provided a human-friendly version of all the different SQL queries that the app will run to interact with the database. So in addition to line charts and bar charts for the numerical data, there is also a map that's been implemented. This is an open source map using a JavaScript package called Leaflet. I think it's leaflet.js, and then that uses an openly available map website or implementation called OpenStreetMap, and these are all available. There are a number of good examples online for how to render these in HTML and then get the map to show up in something like Flask or Streamlit. So this map has different crime incidents colored based off of what happened. And then if you click on them, it also shows just additional information, whatever would appear down here, but up here in a tooltip. So area, location, the crime that occurred, and then the date along with its ID.